Hey, it's Tal from LightTag. In this video, I'm going to show you how to upload pre-annotations or your model's outputs into LightTag so that you can display them to your annotators as pre-annotations like this, right? Or do analytics on them such as intermodal agreement or precision recall metrics that we provide and showed in a previous video. So this video is going to be a little bit more technical, and we're really going to dive into working with the API and preparing data. So enjoy. So we're going to be going over this notebook that is available on GitHub. The link is in the comments and available through our documentation site. And basically what we're going to be doing in this is analyzing two data sets. So data from the Federal Register, which is a collection of rules and proposed rules from the American government, and then a separate collection of political tweets from Twitter. And we're going to run 4 different models on them and put all of those suggestions into LightTag so that we can quickly empower annotators to work faster and also compare the models to see which one is best for our use case. So the 4 models we're going to be using are 2 from Spacey, their big model and small model, Zalando's Flare model, and Stanford's Core NLP model, which we're going to be running as a Docker container. This is the command to run it in the background. All of these models have an NER component, named entity recognition component, and kind of to get them to work together, we're going to have to go through the following steps, which is what we're covering in this video, right? So the first thing we're going to do is we're going to write utility functions that take the output from each one of these models and put it into LightTag's expected format. The next thing we'll do is get the data from LightTag so that we'll have the IDs of every example we're processing and can register all of the suggestions. The next thing we have to do is, even though all of these models are doing named entity recognition, they all have subtle differences in their outputs, and we have to unify or normalize that output so that we're able to compare apples to apples. For instance, Stanford outputs organization while Spacey outputs ORG. And they really mean the same thing, but by default those would be different, so we need to normalize them. Once we've done that, we'll actually create the suggestions, we'll upload them to LightTag, and then we'll go ahead and review that data like we did in the previous video. So let's get started. Alright, so the first thing I'm going to do is import this LT session object, which is essentially a thin wrapper over our API. And if you don't have it installed, you can get it from over here, from this gist. The link is included. And then we'll import Spacey. We'll import the request library, which we'll use to talk with the Docker container for Stanford. The regular expression library, which I'll show you why we're using it in a minute. Pandas for a bit of analytics and self-registration. And then Flare from Zalando. Alright, so the first thing we're going to do is make kind of a connector or utility function to talk with Stanford. And Stanford has 2 little funny things that we need to take care of. So the first thing is that it trims the white spaces at the beginning of ends of a sentence. And that means that if you have a hidden white space that starts off your sentence, the character offsets that it's going to output are wrong. So we wrote this little regular expression that finds white spaces at the beginning of a piece of text. And we calculate any offset that we might need. Alright, so then per given entity that Stanford gave us, we extract the start and add the offset, the end and add the offset, and then we return this LightTag object, right, the LightTag suggestion object, which has the example ID, the ID of the piece of text that we just put a suggestion on, the start, the end, the tag that Stanford gave us, and then we don't need this for LightTag, but it's usually very helpful for reviewing and debugging the value. So what was the piece of text that the model had annotated? And once we have this utility function that converts from Stanford's format to LightTag's format, we'll write one more utility function that actually makes the call to Stanford, right? So again, we're using Stanford's Core NLP model inside of a Docker container, so this is its URL. And then the function essentially gets a LightTag example, so that's a dictionary, and it returns a list of results, of suggestions. And so the first thing we have to do with Stanford is encode that text into bytes, and then we post it to the Docker container. And then Stanford will chop our document into sentences, so we iterate over each one of those, and then for each sentence we take an entity out, convert it into LightTag's format, and then we have to do this check, which is another funny thing that only Stanford does. So Stanford's Core NLP model might make 2 overlapping suggestions, and in LightTag that is a no-no. And so to take care of that, here we're just kind of going to hack around it. and track the cursor, the last position of an annotation, and will only add the next one if it's shifted over past the previous one. So you typically won't have to do this. It's kind of a rare occurrence that a model does that, but Stanford's does, and we need to be aware of it. So the next thing we're going to do is use the two models from Spacey. And I've already pre-installed these on my system, but if not, the Spacey documentation is amazing and it's very easy to install this. So we're going to use the big model and the small model, which are just differently sized models or differently sized training sets. Again, we write this converter function that takes a LightTag example and the Spacey's outputted entity and converts it into LightTag suggestion. So we return the example ID, the start, the end, the tag, and for debugging purposes, the value, the thing that was actually annotated. And then we make two more utility functions, so process with Spacey big and process with Spacey small, each of which takes the content from an example, iterates over the entities, appends them to the list of results, and returns that. Similarly, or very similarly to Flare, right? So we load the Flare model, and the warning to anyone trying this at home, if you're using a CPU like I did, then it's a bit slow. So you might want to limit the size of the data, at least when you're playing around at the beginning. But aside from that, again, we convert the Flare model to LightTag suggestions, example ID, start, end, and tag, and the value for debugging. And then we call the Flare model for every example with this function process with Flare. So that's kind of the first piece of overhead, or how we interact with each one of these models. And then, because we want to be efficient, we'll do one more function that just kind of runs all of the examples or all of the data that we're going to be annotating on all of the models at once. So this function, process multiple examples, gets a list of examples, and it's going to return a dictionary with two keys, models, which are going to be what each model outputted, all of the suggestions, and example IDs, the list of examples that we had seen, and we'll get back to why we want to use that a bit later. But this function is fairly straightforward. We iterate over every example. I like to enumerate them. You don't have to. And then in this models dictionary, right, that's named, we already have an empty list, and we just append to it the output. So we append the Spacey big output to the Spacey big list, the Spacey small output to the Spacey small list, the Flare output, which I disabled before because it was slow, to the Flare list, and Stanford's output to the Stanford list. Great. And once we did that for every example, then we return this kind of dictionary of the models and the example IDs. The next thing we do is retrieve the data from LightTag, and so we're going to initiate a session. So my fake credentials, but you can try them if you'd like. We're going to associate it with the workspace, so our workspace is demo, but yours might be your company name or your personal name or whatever workspace name it is you chose. And then we're going to pull two data sets from LightTag from the examples endpoints. So we're going to pull the Federal Registry data set that we had already preloaded and the tweets data set that we had already preloaded. And then, just for convenience's sake, I'm going to concatenate those two. These are essentially two lists of examples, so I'm going to concatenate them so that we have one big list. And these are the counts. So we have 1,800 Federal Registry examples, 6,000 tweets, and a total of 8,262 examples to process. And once we have that in place, the next thing we do is take all of our examples and call our lovely utility function process multiple examples on all of them. And we get back this results dictionary with model outputs, right, that we've gathered. And then we're done. So now we've finished kind of the scaffolding stage. And before we're ready to upload the suggestions to LightTag, we have to do one more thing, which is normalizing the tags of each one of these. So I've already prepared a dictionary that does this, but if you're running this at home on a larger data set or a different set of models, you might want to do this process yourself again. But basically, we want to normalize things that are the same. So organization is org, and I really don't care about the distinction. For my use case, cardinal and number are equivalent, so I want to map them together. To be able to compare apples to apples, I'm going to unify state or province and country and city with geopolitical entity, GPE, and then location and lock as well, just for the sake of convenience here. And then we're going to write a few more utility functions that use this dictionary to take any particular tag and replace it if needed. So this replace if needed thing takes the actual tag name, looks it up in the dictionary. If it is, gives it the corrected value, otherwise returns itself. So maybe not in here is, I don't know, time. So time would not be found and then time would be returned. And then we actually normalize the suggestion object with this function, normalize suggestion. And finally, we iterate through each one of the models to unify their names. Now, I should say, if you already have an existing schema and you're using your own predefined model that's operating against that set of tags, you don't need to do this process. But if you are, like me, gathering annotations or tags from different sources that have slightly different conventions, then you need to do this unifying step if you want to compare things. Okay, so now a quick thing. We want to check ourselves just to do a quick sanity check and see that there's no other tag that kind of stands out. And the way I like to do this is to load all of the suggestions into a data frame from pandas. So I'm going to make an empty data frame over here, and then I'm going to iterate over the model outputs. And for each one of them, I'm going to create a new data frame. I'm going to add a column to it called model and just fill it with the model name. And then I'm going to append it to the all suggestions. So finally, all suggestions is going to be this one long data frame with all of the suggestions that I've made and the associated model name. And I can pivot it like this to get quickly a list of all of the tags and how many times each model stated them. Now, this information by itself isn't very informative or useful for NLP. What it is useful for is like a quick way to see, are there other tags that are kind of overlapping and I get rid of? So before I made that dictionary, I had things like, I don't know, number and cardinal. They were really the same for me, so I unified them. And I can still see Stanford and criminal charge and cause of death are only set by Stanford, and very rarely, I probably don't really care about them. So I could remove them, but they're too small to matter. So again, if you're merging multiple models or annotations from multiple sources, this is a nice trick to be able to quickly recognize, hey, do I need to unify something? Are there things that are overlapping or really the same? Or are there tags that I want to get rid of because I don't actually care about them? So for me, everything looks good. And the next step that I'm going to do is define a schema in LightTag. So you're probably familiar with this concept, but just in case you're new to LightTag, basically LightTag holds a schema, which is a collection of tags, and when we do annotations with a human or with a model, we want them to always do that under that particular schema. So it's kind of a constraint that says this is the universe of concepts or tags or classes that we are allowed to talk about. And so to define our new schema, I'm going to take all of the tags from the data frame by calling the unique things and converting it to a list. And then I'm going to make this object schema definition. I'm going to give my schema a name, and I'm going to give it the list of tags. And it expects a list of objects. Each one has a name property and a description, which I'm going to generate from the tags that I calculated over here. Okay, so once I've registered my schema, I'm going to get back this response, and it's going to have an ID, and I'm going to use that ID in a minute to register my models. But great, all right, so now we're at our last major step, which is actually registering the models and uploading suggestions. So far I've been saying Stanford is a model and CoreNLP is a model, and it's not like we're going to take those binaries and put them inside of LightTag. We're going to take the outputs that we've calculated and upload those into LightTag, the suggestions. But we want to be able to associate a particular suggestion with a particular model so that we know who said what and can analyze it. And the way we do that is by registering a model in LightTag. We're going to iterate over each one of those model outputs. Remember, this is a dictionary of lists where the keys are the names of the models. So we're going to make a model definition, and we're going to say it belongs to the schema with this particular schema ID that we captured before. And then we're going to give it a name. So, the model name, the key from the dictionary. And then if you want, you can add any particular metadata that you're interested in. So I just gave an example of adding a keyed list, but you can also add, a JSON object with the version and a link to the source. And then if you want your model weights, but that would be slow to upload. I don't know, the literal regular expression you used, the list of keywords, whatever it is. So you can put all of that in there, and you'll always have that data associated with the model. So now that we have the model definition and we're iterating over our model outputs, we're going to register the model by calling the model registration endpoint. It's going to give us back a model object with an ID and a URL. And what we're going to do then is save it kind of in a little cache for later. And then we're going to take the URL property on that model, append the suggestions endpoint, and upload the suggestions that model made. So again, model outputs is a dictionary whose keys are model names and values are lists of suggestions that that model made. So this means send me all of the suggestions that say model name Spacey made, right? And once we do that, the suggestions are up. So now we have one more step, and this is an interesting one that I think is somewhat counterintuitive. But remember in the very beginning when we were calculating all of the suggestions, we also held a list of example IDs that were seen. Well, LightTag uses those if you'd like, and we call them a testament. And the idea of a testament being that if a model makes a suggestion, then we know that it's seen the example that it's suggested on. But sometimes it'll look at a piece of text or an example and it won't say anything. But you still want to know that the model saw it and said nothing because later on when you calculate agreement and precision recall metrics, you need that information. So this isn't mandatory, but it really improves the quality of your analytics if you upload the list of examples that the model had seen. And we call that a testament, right? So the model is attesting to the fact that it saw this example regardless of whether it gave a suggestion or not. Again, this is an optional step, but it improves the quality of the analytics that we can provide. And once we've done all that, then we're good to go. So we describe it here in the notebook, but we can just look at LightTag. So the second I've uploaded those models, I immediately get inter-model agreement, right? So, and the way to read this would be, so looking at the Spacey small model, it made 455 annotations. And then when I compare it to Spacey Big, they shared 455 annotations. They both gave a testament to all the examples, and those contained 450 annotations. And they agreed, and Spacey Big agreed with Spacey Small 346 times. Now, on the other hand, if you look at Spacey Big, it has a shared pool of 480 annotations with Spacey Small. It made more annotations than Spacey Small, and they agreed 346% of the time. So that means that Spacey Big agrees with Spacey Small 76%, while Spacey Small agrees with Spacey Big 72% of the time. And that's a bit of a drill down, but it gives you a quick level of understanding of, hey, is having these multiple models informative? Are they conflicting? Are they all in unison? Is it even worth my time to kind of investigate them? But it looks like yes, so there's quite a high level of conflict and variance between these. And then the next thing we can do, as we described in the previous video, is just review them one by one. And that means that we go into review mode again. And it'll show us every time that a model or multiple models made an annotation and if there was a conflict. So Secretary of the Interior, 2 models captured that phrase, but one said it was an org, one said it was a title, which is great. And one model just labeled Interior as an org. So we're going to accept that, and LightTag is going to record Secretary of the Interior is correct and reject org and Secretary of the Interior as an org. And so we're going, again, the United States, so we have United States with a period at the end, and the United States. So we'll take number 1, the United States. Once we save these, we get a final layer of, we get 2 things actually. So first of all, we get a golden source of data that we can download from over here. And this will just give us the things that we reviewed and accepted, which is a very high quality, high precision data set that we can further use to train the models. And we also have some additional analytics that we can get on our models. So at the most basic level, we can get kind of a precision recall metrics on each of them. And we can break this down by schema or by data set. But how many true positives, and false negatives a model had, and the precision and recall and F1 score. And then we can drill down into a particular model to see what it did. So let's look at Flare. Right, so Flare is already selected for me, and I just want to see the list of its false negatives. So I'm going to select that, and we can group it by tag over here. and then kind of start asking ourselves, well, why is Flare missing these fairly easy GPs like Fort Lauderdale in the United States, etc. So again, that was how we use the models once we've uploaded them. But the core of this video was actually about uploading it through this notebook that we've shared. I hope that's been helpful. Let me know if you have any questions. You can reach us at support@lighttag.io or through the chat window, or just through your demo sites. Thanks a lot for watching, and best of luck in your annotations.